Welcome to the bleeding edge of artificial intelligence. If you thought the last few years were groundbreaking, you haven't seen anything yet. We are standing on the precipice of an AI revolution so profound it will redefine intelligence itself. It is early 2026. The world has moved past the novelty of simple chatbots. We are now in the era of the frontier models, systems so large and so capable that they are no longer just software. They are industrial-scale digital brains. Leading this charge are two titans, OpenAI's GPT-6, the rumored heart of Project STARGATE, and Google's Gemini 4, the model built to be a world model. For years, we've watched these two go head-to-head. We saw GPT-4 meet Gemini 1, then GPT 5.1 face off against Gemini 3. But the leap we are discussing today is different. This is the race for AI supremacy. Is it feasible to jump into this space now? Absolutely. Because while these models aren't yet available for the open market to download, the battle lines are already drawn in research papers, patent filings, and the massive data centers rising in the American desert. Today, we are going to dissect the architecture, the agents, and the real-world utility of the next generation. We will explore the $500 billion infrastructure projects, the shift toward agentic autonomy, and the looming 2027 milestone that many researchers believe mark the arrival of AGI, artificial general intelligence. To understand GPT-6, you have to look at the physical world. In 2025, a massive joint venture was solidified between OpenAI, Microsoft, SoftBank, and Oracle. Its code name, Project STARGATE. This isn't just a bigger server room, it is a $500 billion industrial complex designed to solve the two greatest bottlenecks in AI, silicon availability and energy. As of early 2026, the flagship STARGATE site in Abilene, Texas, is officially operational on Oracle Cloud infrastructure. Larry Ellison of Oracle has confirmed that they are building 10 500,000 square foot buildings, each drawing nearly a gigawatt of power. OpenAI, Oracle, and SoftBank expanded this vision with the announcement of 5 new data center sites late in 2025, moving toward a 10 gigawatt commitment. To put that in perspective, 10 gigawatts is enough power to support a small country, all dedicated to training and serving a single intelligence, GPT-6. This is what 10 gigawatts looks like, not in spreadsheets, not in press releases, but on the ground. Roughly 12.5 million solar panels stretching across tens of square miles. This is the kind of energy commitment required to power frontier-scale artificial intelligence. Compute at this level doesn't just live in the cloud, it lives on the land. Why the desperate need for such scale? Because GPT-6 is moving into the realm of the tens of trillions of parameters. While GPT-4 was estimated at over 1 trillion, researchers suggest GPT-6 could range from 20 to 50 trillion parameters. Training a model of this density requires hardware that didn't exist 2 years ago. We are seeing the massive deployment of the NVIDIA GB200 Blackwell racks, which began delivery in mid-2025. These systems are liquid-cooled and designed to treat an entire data center as a single unified computer, allowing GPT-6 to process quadrillions of tokens. Now, let's look under the hood of GPT-6. The primary goal for this model isn't just more data, it's a fundamental change in how the AI interacts with you. Sam Altman has explicitly stated that memory is the key feature for this generation. Historically, every chat with an AI was a fresh start. You had to re-explain your preferences, your coding style, or your project goals every time. GPT-6 introduces dynamic persistent memory. It is designed to record and recall preferences, ongoing projects, and past conversations over weeks or months. OpenAI's vision is a personalized collaborator that understands your routines and quirks, adapting its worldview to match yours. But the real game changer is agent mode. While GPT 5.1 introduced basic agentic behavior, GPT-6 is built to be an autonomous operator. It is expected to break complex goals down into actionable plans, integrate with external APIs, and browse the web or navigate your computer to actually do things for you, rather than just telling you how to do them. This moves the AI from the level 1 operator role into level 2, or even level 3 autonomy, where it can drive decision-making in a workflow. This architectural shift is also mirrored in its multimodal reasoning. GPT-6 doesn't just see an image, it understands the intent behind it. Whether it's analyzing a complex technical diagram or a piece of creative writing, it uses improved reasoning to maintain continuity and deeper logic across sessions. While OpenAI is focused on building the ultimate digital brain, Google's strategy with Gemini 4.0 is to build the ultimate world model. But what does it mean for an AI to be a world model? Most models, including earlier versions of GPT, were primarily text-based with multimodal capabilities bolted on later. Gemini 4.0, however, was designed from the ground up as a native multimodal system. In 2026, Gemini 4.0 doesn't just read an image by converting it to text first. It perceives the visual, auditory, and spatial data simultaneously. This native multimodality allows it to reason across different types of media with human-like fluidity. If you show Gemini 4.0 a video of a complex physical interaction, like a person building a piece of furniture, it doesn't just see a sequence of frames. It understands the 3D relationships between the objects, the physics of how they move, and the intent behind the person's actions. This is the realization of Project Astra and the Genie research from Google DeepMind, which aim to create general-purpose world models capable of generating and understanding interactive 3D environments. For you, the creator, this means an AI that can watch your rough video footage and give you feedback not just on the script, but on the lighting, the pacing, and the spatial composition of the shot.
Composition really matters, you see. If the lighting isn't right, the whole feeling of the moment is lost in the shadows.
One of the most defining technical features of the 2026 AI landscape isn't raw intelligence. It's memory. More specifically, the explosion of the context window. While GPT-6 has made massive strides in reasoning and internal deliberation, Google remains the industry leader in long context processing. Gemini 4.0 Pro and its enterprise variants now ship with context windows that can handle up to 2 million tokens. That number is hard to grasp until you slow down and put it into perspective. 2 million tokens is equivalent to thousands of pages of text, hours of high-definition video, or an entire million-line code base being held in the model's active working memory at the same time. Not searched, not retrieved, held. For years, this limitation forced developers to rely on complex retrieval augmented generation systems, RAG, where the AI had to search external databases just to find the right fragment of information. That worked, but it was always a workaround. With context windows at this scale, RAG becomes unnecessary for most personal and mid-sized business projects. Instead of the AI searching your data, it reads the entire project every time you ask a question. The result is near-perfect recall, the ability to find needles in haystacks like a single bug hidden in a 100,000-line repository, or a 3-second moment buried inside a 4-hour video file. And this is where the shift becomes qualitative, not technical. In 2026, the context window isn't just a specification. It's the difference between an AI that knows about your project and an AI embedded in your project, present, aware, and working with you, not around you. By early 2026, researchers have standardized how we talk about AI autonomy through a 5-level taxonomy of agents. Understanding where GPT-6 and Gemini 4.0 sit on this scale is crucial for predicting how they will change our lives. Level 1. Deterministic task bots. These are the basic automations we've known for years, rule-based systems that perform narrow tasks with zero autonomy, like a simple password reset bot. Level 2. Preparatory agents. This is where GPT-4 and Gemini 1.5 live. They can draft emails, summarize documents, and propose multi-step plans, but they always require a human to review every single step before execution. Level 3. Narrow operators. This is 2026 baseline for models like Gemini 4.0 Flash. These agents can handle routine workflows end-to-end, such as managing weekly expense reporting or closing out support tickets, and only escalate to a human when they encounter an anomaly they haven't seen before. Level 4. Semi-autonomous specialists. This is the frontier where GPT-6 and Gemini 4.0 Pro are currently clashing. A Level 4 agent operates the vast majority of the time, approximately 98%, correctly. It can autonomously plan, use tools, and recover from common failures. For example, a Level 4 travel agent wouldn't just suggest a flight. It would monitor prices, rebook if a cheaper option appears within your policy, and handle the cancellation of the original ticket without you needing to click approve for every step. Level 5, autonomous problem solvers. This is the PhD level of AI. These are agents that can pursue open-ended goals, decompose novel problems they've never seen, and generate entirely new strategies to solve them. As mid-2026 approaches, most experts believe that true Level 5 autonomy is the target for 2027 and beyond. The race between OpenAI and Google in 2026 is essentially a race to see who can move the most users from Level 2 assistants to Level 4 operators, safely and reliably. In the developer landscape of 2026, we have moved beyond autocomplete. We are now in the era of autonomous software engineering. For professionals, the choice between GPT-6 and Gemini 4.0 depends on whether you need a brilliant architect or a comprehensive repo explorer. GPT-6. The master architect OpenAI continues to hold the crown for precise reasoning and debugging reliability. GPT-6, powered by the upcoming 03 Pro and 04 Mini High models, is designed for software-level control. Encoding benchmarks like SWE Bench Verified, which measures the ability to resolve real-world GitHub issues, OpenAI's latest models consistently rank at the top, often hitting over 76% success rates. GPT-6 doesn't just write code, it provides architecture explanations and DevOps workflow optimization. It is preferred for code-heavy projects because it takes a practical approach, often providing real-world usage examples to ensure the developer understands the underlying logic. With the release of Codex 5.2, OpenAI has turned the AI from a simple assistant into a real coworker, capable of managing complex multi-file migrations and deep logic debugging. Gemini 4.0, the Repo Explorer. Google's Gemini 4.0, however, wins on multimodal technical explanations and visual debugging. Because Gemini was designed from the ground up to be multimodal, it can see your UI. If a button is misaligned or a CSS animation is flickering, you can simply share your screen or a screenshot, and Gemini will trace the visual glitch back to the specific line of code. But Gemini's true unfair advantage is its context window. While GPT-6 focuses on deep reasoning within specific snippets, Gemini 4.0 Pro can hold up to 1 million to 2 million tokens in active memory. This allows it to ingest your entire repository at once. It understands the global dependencies of your project, how a change in a back-end API might break a front-end component 3 directories away. For developers working in vibe coding environments like Google's anti-gravity IDE, Gemini 4.0 allows for the creation of entire applications from simple conversational prompts. The divide in creative writing has become equally distinct. By 2026, OpenAI and Google have optimized their models for very different styles of storytelling. GPT-6, the nuanced storyteller. GPT-6 is the undisputed winner for creative content generation and conversational style. OpenAI has focused on making GPT-6 sound more human and less robotic. It excels at maintaining a consistent tone and can be customized to write in professional, casual, or even comedic voices without the need for repetitive prompting. One of the most significant leaps in GPT-6 is its hyper-personalization. Through its persistent memory layer, it remembers your professional goals, the names of your fictional characters, and the specific technical specifications of your world-building projects over months of collaboration. It avoids the cliches and predictable patterns of earlier models, offering more nuanced dialogue and even exploring edgy or unexpected narrative directions that feel original rather than generated. Gemini 4.0, the grounded world builder. Gemini 4.0, conversely, is the master of research-focused, grounded storytelling. Because it is natively integrated with Google Search, it prioritizes accuracy and source citation. If you are writing a historical novel or a hard science fiction piece, Gemini 4.0 acts as a literature agent, ensuring every detail, from the weather in London on a specific day in 1940 to the physics of a black hole, is factually grounded. Google's Gemini Live and multimodal tools also allow for a new kind of visual storytelling. You can brainstorm a scene orally with Gemini, then use its integrated Imagen 4 or VO3 engines to generate character mock-ups or 4K video clips of the setting directly within the chat. It is less about writing for you and more about being a multimedia storytelling partner that can summarize research, extract insights from long PDFs, and help you visualize your narrative in real time. But as we look at the dazzling capabilities of GPT-6 and Gemini 4.0, we have to address the elephant in the room. In early 2026, the AI industry has hit a wall that no amount of venture capital can immediately fix: the physical reality of infrastructure. We are currently in the midst of what historians are already calling the Great Memory Shortage of 2024 to 2026. While everyone was focused on the GPUs, the real bottleneck shifted to HBM, high bandwidth memory. To run a model the size of GPT-6, you need tens of terabytes of ultra-fast RAM just to hold the weights of the model in active memory. By late 2025, major manufacturers like Samsung and SK Hynix began reallocating nearly all their wafer capacity to AI-specific memory. The result? A 60% hike in memory prices that has rippled across the entire tech sector. For the first time, we are seeing silicon inflation. This is why your favorite AI tools are suddenly introducing higher-tier subscriptions or usage credits. It's not just corporate greed, it's the raw cost of the electricity and the HBM required to process a single prompt. And then there is the power. We mentioned Project STARGATE's 10 gigawatt goal earlier, but the broader grid simply wasn't built for this. In 2026, AI data centers are expected to consume roughly 3.5% of the total US GDP in capital expenditure and power. We are seeing a shift where AI companies are becoming energy companies by necessity. Microsoft and OpenAI are reopening nuclear facilities, while Google is investing heavily in geothermal and small modular reactors just to keep the lights on for Gemini 4.0. There is a massive economic shift happening right now that most people aren't talking about, the great inference reversal. For years, the story was about the training phase, the billions spent to teach the model. But in 2026, inference, the cost of the model actually answering your questions, now accounts for over 55% of all AI compute spending. Why? Because of the agents. A simple chatbot answers once and stops. An agentic system powered by GPT-6 or Gemini 4.0 doesn't just answer, it thinks. It engages in continuous reasoning, loops back to check its own work, uses tools, and operates for hours on a single goal. This continuous compute means that running an agent is roughly 100 times more expensive than a simple query. This is forcing a bifurcation of intelligence. We are seeing the rise of small language models, or SLMS. For routine tasks, companies are moving away from the God models like GPT-6 and towards smaller distilled models that run on-device or on local servers to save costs. In 2026, the mark of a sophisticated AI user isn't just using the biggest model, it's knowing how to orchestrate a swarm of smaller models to get the job done efficiently. As we wrap up this look ahead, we have to talk about the year 2027. In the research community, 2027 is treated with almost mythical significance. A landmark report titled AI 2027 has set the stage for what many call the takeoff year. Sam Altman has famously predicted that we might reach AGI, intelligence that matches or exceeds the median human across all cognitive tasks, in a few thousand days. Demis Hassabis at Google DeepMind is more cautious, pointing toward the end of the decade, but even he admits that 2 or 3 big innovations are all that remain between us and that epochal moment. In 2026, we are seeing the final pre-AGI models. GPT-6 and Gemini 4.0 are the systems that will build the systems that eventually surpass us. They are already being used to automate AI research itself, helping to design more efficient chips and better training algorithms. We are in a self-reinforcing loop. So, who wins? In the race for raw intellectual supremacy, OpenAI's GPT-6 remains the heavyweight champion. Its STARGATE backing and focus on deep, PhD-level reasoning make it the choice for the pioneers and the power users. But in the race for global adoption, Google's Gemini 4.0 is winning the ground war. By late 2026, Gemini usage is projected to surpass ChatGPT consumer usage for one simple reason: frictionless integration. Because Google owns the Android phone in your pocket and the workspace in your office, Gemini doesn't have to be better than GPT-6. It just has to be there. The 2026 battle for AI supremacy isn't just about code or parameters. It's about trust, energy, and ecosystems. We are moving into a world where your AI isn't just a tool, It's an extension of your agency. I want to hear from you. We've seen the hardware, the agents, and the road to 2027. Are you sticking with the superbrain of OpenAI, or are you moving into the universal world model of Google? The comments section is open. Let's talk about the future. I'm Stanley Payne, and this has been the Race to AI Supremacy. I'll see you in the next one.